The next session, the round table number 1. The round table is about the provision of the engineer ICT in Europe. The chair is Edward Smith, the FITCE UK, and the participants, the president of FITCE and the FITCE Italy, Maurizio, Ralph Meersman, the FITCE Belgium, and the Dulka, the FITCE Poland, and Maria Nuño, the FITCE Spain. Mr. Smith, have you floor.
Yes, I'm ready. Thanks very much, Miguel. Welcome to this session. It's been an excellent lunch. The chairs are very comfortable, but I'm sure we'll provide lots of stimulating content to keep you awake. I'm joined by an eminent panel. On the far left, we have Andrzej Dulka from Poland, who holds a PhD in automation, currently president of Alcatel-Lucent in Poland, and he heads the Eastern European region for Alcatel-Lucent and has been advising on the telecoms industry since 1994. Next to Andrzej is Andy Valdar, who is president of FITCE. He was a senior manager with BT and has spent 18 years teaching engineers and non-engineers at master's degree level at University College London, where he still teaches. Next to Andy is Maurizio from Italy. He's been a senior electronics engineer with several major multinational companies and is currently operating as a freelance consultant. He's past president of the FITCE Italian Association. Next to me is Maria Nuño, who's a telecommunications engineer who works for PricewaterhouseCoopers, consulting in telecommunications, most recently in the international banking sector. She's active both in FINI and the AEIT. And next to Maria is Ralph Meersman. He is CEO of a small European software development company, developing innovative software solutions for the telecommunications market and operating on a global basis. He leads a team of more than 20 top engineers with an average age of 28 years. He's also vice president of FITCE Belgium. And if I could hand over to Andrzej, who will tell us a little bit about the future of the industry and a little bit about careers in the east of Europe. Thank you, Andrzej.
Good afternoon, everyone. Well, there is, I'm learning all the time, and I learned today a new definition of a round table. But that is always good, because if Earth is round, that probably I'm sitting next to you, and it's a round table. When I was joining telecom industry and automation by education in '94, I thought, whoa, this is really cool profession. This is really cool industry. I was joining at the time AT&T, and when you joined AT&T, it was welcome on board and lifetime employment, yeah, because we'll be talking about engineers, and we'll be talking about a bit of our fate and what happens with engineers in our industry. And we were talking about, at that time, Poland was a telecommunication country that when the rain drops, there was no communication. And when you wanted to make an international call, you were selected the day after tomorrow at 1 o'clock, you had to be at home, and then you got the international call. There was a joke that at 1 o'clock at 9, a phone calls, and the commuter is asking, hello, sir, did you ask a call to US? No. So you better start talking, because I put you through. So this was the state of telecommunication. And we were talking today about couple of industry revolutions. And we remember that from agriculture, industrial, we had that all. But do you know that it was everything before 1990? 1990 is the year of beginning of internet. And do you know how many revolutions did we have from that time? Well, I'm a lucky guy because I still work in a company that has Bell Labs. AT&T had Bell Laboratories, then I worked for Lucent Technologies that had Bell Laboratories, then I was working for Alcatel that had Bell Laboratories. Now I worked for Nokia, they still have the Bell Laboratories. And those smart guys in Bell Laboratories, they wrote a book, I read the book, I will share with you the information, so it's not my wisdom, you can trust it. It comes from Bell Labs. So there were a couple of revolutions. From 1990 to 1995, the internet was a browsing internet, 5 years. And you probably remember such application as Mosaic. 95 is a year till 2000, it's 5 years. The internet became the internet of searching. Google arrived. 2000, 2005 is internet of personal content. We suddenly could put personal content on the internet, and you probably know such applications as eBay, Napster, and others. 2005 till 2010 is another generation. Video and e-goods appeared on internet. And such things like Netflix, YouTube, Facebook, well, they are already a bit of fishy. They are old-fashioned, because then, 2010 to 2015, came another era on the internet. And then another era of internet is personal content. And you know such things like Instagram, like Apple, they appear. And 2015 onwards is another generation. We are talking about Internet of Things and all connected devices. So look, 2019, 2020, we had already 6 revolutions. And what it says about welcome on board and lifetime employment, well, you know, the moral life of equipment is only 5 years. It still could go on, but after 5 years, you have to learn new equipment, new technologies, new things. And I will give you one example. We at the beginning of telecommunication, we were doing everything in Erlangs. You remember, Erlangs was the thing you have to know to build telecommunication. Today is no more anymore. A lot of today we talk about, if you remember, latency. What is latency? We are not talking about jitter. We are talking about latency. The moment I issue a signal till the moment I get a response, this is a latency. Yeah? And do you know what is visiburo-ocular reflex? I will demonstrate that to you. This is visual ocular reflex. My brain needs 7 microseconds when I'm moving my head for my eyes to adjust that I see it correctly. Why is it important? When I will be driving in a self-driven car, I don't want the car to jitter. I want to have the comfort that the car responds in live situation to what is happening. And where is the telecom infrastructure there? And where I'm talking about telecom here? Well, if I want to be in a good situation, let's make it simple for our calculation. Let's make it not 7 milliseconds, let's make it 10 milliseconds, it will be easier for calculation. Light has a limitation, 300,000 kilometers per second. If you reduce that to 10 milliseconds, it is 30,000 kilometers. Now, the light from my car has to travel to the server somewhere, come back, and has to be processed. And the acceptable situation that we can accept is that the server will be within a distance of 70 or 100 kilometers, because my car has to process the information. It has to be sent. The servers there has to process that and come back. Why is it important? It is important because what we were talking about latency today, it defines the network in a new way. You will have in the edge of your network, countrywide, a dense network of access infrastructure and processing power. And what we are talking today about that those global guys, this Netflixes, Googles, they will dominate the whole telecommunication, yes, globally, with their offering. But what they would need locally, and they will not survive without that, is a dense network provided by local service providers. They will come to the local service providers with an offering. Either they will start to build that by themselves, or they will liaison with local guys. The Bell Labs guys predict that somewhere in the 2020-2005, there will be 10 global service providers and something like 100 worldwide local service providers. And just to come to conclusion, because I can talk for quite long, I would like to share with you 3 notions that define that we design networks totally different. One concept is the concept of network function virtualization. What is this? Some smart guys defined that not all functions of specific feature has to be in the local equipment. They have to be. They could be softwareized, they could be taken away. Not everything could be virtualized. Well, the local access, the copper will not be virtualized. There are things that have to be physically there. But the smart guys identified that whatever could be put in the software could be put away. It's better because it is virtual. On the second hand, we have software-defined networking. Software-defined networking in very simple terms means that the network adjusts to the services you provide. Software-wise, it rules the network in such a way that the components of the network, the equipment that is there adjusts to that. So on one hand, you have network function virtualization. On the second hand, you have software-defined networking. And here we are coming to a very interesting space. We are coming to a very interesting space because everything could be run by software. And if everything could be run by software, and if you put more and more intelligence into that network, and I hate the word artificial intelligence, I like the word augmented intelligence, because nothing will replace our brain. But there will be software that will augment our intelligence. If you start to put augmented intelligence in the network, suddenly the network lives by itself, it manages its components, and you have a network that you have input, you have output, but you don't know what the network does and how it does. You say it's fiction. No, it's not fiction. It already exists. There are service providers in states, I can't mention, that have augmented intelligence embedded into their network, and this augmented intelligence is running that network. They see efficiency of the network, they see outcome of the network, but they don't know why. And think how much profession of a telecom engineer has to change from that guy who was calculating Erlangs to that guy who has to define that network today. It is no more mesh. It is no more tree. It is based on graph theory. The network of the future will be engineered on graph components. Our profession is fascinating. It changes each year, or each 5 years, as I mentioned. There is more to come, and if you believe this is the moment where the progress has started, no. It ended, no. It's the moment where the progress has started. Have you heard about bits? Of course, bytes. But do you know what is qubit? In 2020, 2005, there will be first prototypes of quantum-based computing. I have seen that in the laboratories already in our company. Quantum-based computing is not based on 0 ones. It's on my language, on very big number positions where the quantum could be localized. It's totally different programming. The term qubit already exists. The logical, mathematical theory of programming in qubit-related language already exists. 2025, it will start. What it means? Actually, one would say it's just a technological revolution. Well, if current computers need the lifetime of universe to break a code that is based on prime numbers, computer of quantum, based on quantum computing, will do that in a real time. So we are no way at the end of revolution. It's only beginning of the revolution, and the role and fun of our engineering profession will continue. It means, yes, lifetime employment, but in probably a couple of different professions during our lifetime. I wanted to share with you that my passion and vision of Bell Labs in a couple of words. I hope it wasn't too long, and I knew that I have fight with your brain, with your blood gravitating to your stomach. I hope I managed to put that a bit up.
Thank you, Andrzej. So you all now know that you're revolutionaries, and Maria is about to tell you a little bit more about the nature of the revolution in Spain.
Thank you. Good afternoon, everybody. I would actually thank you, all of you, for coming today. And also thank you, the Spanish Association of Telecommunications Engineers, for organizing such an interesting congress. And of course, it also thanks to you and the rest of my table mates, because it has been very easy to work with all of you. So my presentation will talk about the following items. First of all, I will want to explain a quick overview about the different studies of related to telecommunications engineering in Spain. Then we are going to see some very interesting data about employment for professionals related to telecommunications engineer. Afterwards, I will talk about some institutions who support engineers. And finally, I will share with you some challenge that we have as part of our role in this digital world. So let's talk about studies. We have two different kinds of studies here in Spain. On one hand, we have a university graduate, which is similar to a bachelor, and also graduates plus a master, which is the same as a Master of Science. The average time to complete these studies is 6.5 years, and I'm very proud of this group of students. Although you are still studying at university, you have joined all of us today, and that means that young people is really conscious of the telecommunications profession perspective. Regarding data, before I start talking about data, I will actually thank Adrian, Olympia, and IDC, your brilliant work with this study we are going to start talking about. And next month, the Spanish Association of Telecommunication Engineers is going to launch the latest study about the telecommunications engineers profile. Regarding that, we have realized the following data. The typical profile of a telecommunications engineer is a man. 82% are men and 18% are women, but this rate is growing. As in 2012, the rate was 15%. This is a very stable sector with natural unemployment. That means that our rate of unemployment is very low, near 4%, half than in 2012. And just as a clarification, the Spanish average of unemployment is near 18%. Telecom engineers work in three kinds of areas, such as technical, management, and sales. And the average salary is around 60,000 euros per year, twice the national's average. We work 40 hours per week, and the level of satisfaction is increasing as our work-life balance. 93% engineers are working in Spain. And now we are going to talk about the institution which are supporting the telecommunications engineer. First of all is the Spanish Association of Telecommunications Engineers, who support near 10,000 engineers in Spain. We are very close to the Spanish Institute of Engineers, who is supporting more than 500,000 engineers. And also we have a strong international relationships as with FITCE, which is an institution formed by 10 countries, and also FEANI, which is the European Federation of all the national associations of engineers, and is formed by 34 countries, and it supports more than 3 million of engineers around Europe. I just have a quick highlight on the main services of these institutions, and the most popular are some services related with insurance and legal and tax services, also some IT services as our email account. But the most important thing is the strong lobby that our president and the city members are doing with all the public administrations in order to improve the role of the telecommunications engineer in our countries. So, talking about our challenges, our main challenge is not to find a job, it's trying to define the new positions that the companies are needing. And that means that we should define the educational system working near the university and define new studies, because we are needing now new skills. And then we should identify what companies are needing in order to get all of these positions. Lastly, we should continue leading up this digital transition. So, the key message is that if you become a telecommunications engineer is good, and you will be benefited from low unemployment, good salary, a strong support for our groups, and the opportunity to improve and specialize a lot of skills and different areas. So this is more or less the overall from me. Thank you.
Thank you very much, Maria, for that very comprehensive analysis of the Spanish situation. Maurizio will now take over. He's going to give us a general overview of the engineering profession in Italy, particularly drilling down into the IT situation and talking about the new paradigm for market certifications.
Thank you, Ed. Yes, let's start from to give an overview of the Italian situation. Just a few words on the overall engineering profession in Italy. It is ruled by an old law that for 1921, and it foreseen that in order to exercise the profession of engineer, you must have been graduated, to have overcome a state examination, and to be signed to an order like the Collegio here. We have a different organization in Italy in the sense that you in Spain have vertical order, the order of the Collegio of telecommunication engineers and the mechanics engineers. We have already, on the contrary, just one order, but organized locally. So we have the order of engineer of Rome, of Milan, of Venice, and so on. Now, the other thing is that the same law, and all the other that came after, has foreseen that a customer, private or public, that need to have an engineering activity is obliged to refer to an engineer that is registered in an order, but only for some disciplines. Obviously, the discipline regarding civil constructions, electrical connections, and so on. Nothing regards ICT. So you can have the possibility of plan and build a complicated telecommunication network, not being an engineer, not being graduated, and so on. This comes from the fact that that law was regarding this we call reserved activities, just to the activity to which one time was linked the human health. At that time, telecommunication was not considered as something of vital. Okay, so this is the great distinction. But nowadays, the scenario is completely changed because in the virtual reality demonstrator outside that door, they were referring to the telegraph SOS signal that saved a lot of people in the Titanic sinkage. But we can have a lot of examples. So in Italy, we are now facing a double approach to this situation. From one side, people, especially within the engineering orders, are proposing modification to the law in order to include telecommunication networks, information system in the reserved activity. In the other side, we are also a very fast-growing approach, saying, okay, no, let's be the market to define what are the competences. So we are now introducing certifications from international bodies. There are a lot of them on cybersecurity, on project management, everything. Business continuity, that is also an important aspect, and so on. So it's not very clear where the balance will see. Third component, the European Union regulations that is introducing another variable in this scenario, because the European Commission is pushing for have a total parity about the professions within the European Union. No? You remember that the Bolkestein directive, everybody was frightened to have people coming from other countries to make the same job at home. So this of the certifications is any case also a business, because to get a certification costs a lot of money, or to the individual, or to its company. And there is a lot of kind of market also to do that. So this is the aspect. So this morning we have spoken a lot about technologies, and we also continue to afterwards. Our profession is complicated, as Andrzej was saying, and also these other variables are complicating more. You were saying that maybe that in the career we can make two different jobs. I like to quote an American researcher, a sociologist, that's speaking to young people, high school level, was saying, remember, in your future, you will do 5 different jobs. And of these 5 different jobs, 4 are not yet been invented. So, as Maria was quoting, we need to give support to our young colleagues in all senses. And I'm very happy, because I'm here, to remember that the FITCE Spanish Association and the FITCE Italian Association have undersigned an agreement to exchange services across our borders. So the Italian Association will give support to the young Spanish engineers that are working in Italy and vice versa. This is a drop in the sea, but I think that it is also concrete help, and we hope that this example could be followed also from other associations. Thank you for your attention.
Thank you, Maurizio. Very interesting and a nice follow-on. Another nice link is Andy Valdar is now going to talk to us about the recognition of the role of the engineer by society and the need for a rounded education, plus a little bit about the nature of today's ICT environment.
Thank you, Ed. Well, when we think about engineers, in the UK, the same word engineer is used for all sorts of activities. And certainly when I was a boy, an engineer was somebody who drove a steam train. And so there are lots of things that you associate with the idea of engineer. And one of the things I've been involved in for a long time within the UK is trying to recognize that the engineer is more than just somebody who understands the technology. So thinking about what we've heard already this morning and in the previous part of this roundtable discussion, I'm very much minded to say that actually we have no shortage of technology. We've got plenty of technology, thank you. There's a big pile of it over there. And you could say that one of the challenges for an engineer is to know which technology to use and when. And that leads me on to the general theme that I want to develop, really, and that is we are in a complex environment. Things are changing very rapidly. We had a very nice description of that from Andrzej from my Polish colleague on my left. Yes, things are changing very fast, but it's not just the technology that's changing. It's also the general environment, the financial structure, the services, customers' expectations, the way that customers and users use technology and use services. That's all changing. And usually, when standards are set, for example, to decide on a particular technology to go ahead, whether it's encoding or whether it's recording and so on, it's very often not the best technology that's chosen, but the one that's most accepted. So if you think about Internet Protocol, IP, actually, as far as the Internet's concerned, it's not very good. If you were designing the Internet today, you would not design it in the same way, right? There are lots of things wrong with IP. I know we've got version 6 coming along and so on, but nonetheless, the technology that was standardized, TCP, IP, or UDP, all those bits of the layers 2 and 3 of the stack, that's not necessarily the best, but it's the one that was chosen. And that, I think there's a big principle there. And the principle is that engineers really do have to understand that it's more than just the technology that matters. And one of the things I've been involved in for many years, and I was very lucky when I worked in British Telecom for 30 years, that towards the last 15 years or so, I was working in network strategy. And that was where we looked at the big picture. I was very lucky. I had long-term forecast people working for me. I had vision people. And as my boss said, it's either a vision or a hallucination. I'm not sure which, but they actually started to look ahead to see how the world might change, what might this mean for a company like British Telecom or any other telecoms company. And one of the things that I was very fortunate to do was to understand how the strategy, the regulation, the services, the technology that's coming over the horizon from the research labs, customers' expectations, and all the rest of it, how that all fits together. And that leads me on to my main point. I think engineers need to be actually architects. What I mean by being an architect, just like an architect designs a house, and the architect, he or she will work out the floor, the walls go here and the roof's over there, the windows are there, and what's more, the power comes in here and the drainage goes there. So the architect is seeing how everything fits together, and that's what an engineer needs to do. And one of the things that we identified while I was working in network strategy was there are really 4 architectural views, 4 perspectives that engineers need to take. And if you said to somebody who's very well versed in the technology, just design me a data network, they'd grab the nearest piece of paper or a tissue and get their pen out and they'd draw a box and draw a line to another box and so on. But I'm saying that you should remember the 4 architectural views. And the first architectural view, the first thing you draw out, is what is the commercial model that describes what's going on here? Who are the players? Because nowadays there's more than one player. There are ISPs and there are telcos. There may be telco 1, telco 2, telco 3, fixed, mobile, several ISPs, different levels of ISPs, and so on. And then there are other levels to think about. So who's doing what to whom and who's paying for it? And you have to decide that first before you go any further looking at what the design ought to be. That's architectural view 1, the commercial architecture. The second one you move into is thinking about the techno-regulatory architecture. What's the boundary of the network you're designing? What's the network-to-network interface between your network and all the others that you are interconnecting with? That's one boundary. What's the user network boundary, the UNI? That's your other boundary. These are really basic things, but once you've got that, you can now start to think about designing your network system. So that brings you on to the 2 other architectures which most of us are familiar with. The first is the functional architecture. The OSI 7-layer model is a classic example of a functional architecture. By the way, engineers love layers. 7 is actually a bit pathetic. I want to go for a 20-layer model. Actually, if you look at the protocol architecture for 4G or LTE, have you seen how many layers there are? It's a huge number. I think I counted 15, right? That's LTE. And think how much traffic goes over LTE. So when we move on to 5G, can we just reduce from 15 down to maybe 6 or 7 layers in the protocol? So, looking at things from an architectural point of view is very important. And by the way, that'll help latency if you do that. Because all these layers, it's one layer writing into the next layer, which is writing into the next, and so on. That's a key point for 5G. So architects have to be aware, engineers have to be architects to understand these things. So that was view number 3. View number 4 is then the physical view. This box joins to that box, and that box joins to that box, the one that most people love to do. 4 views. So I think engineers have to understand all those perspectives. Now, for the last 60 seconds, I would just say I've been very lucky to be involved in teaching on master's programs, and first of all with British Telecom, and then within UCL as an open course. We've been running courses which are master's programs, which are half engineering and half business. My reason for living most of the time is to run an MSc course known as Telecommunications with Business. For the master's program, half the modules are technical, sort of stuff we've heard over on my left, and half are business, strategy, finance, regulation, and so on. So half business, half technical, and that's what the MSc is trying to teach. We want engineers who understand not just the technology, but which technology to use and when. Thank you.
Thank you very much, Andy. Now we'll take a very different perspective, I guess, from Raf, who's going to talk about his experiences from working with and managing software engineers, particularly with an emphasis on what drives young engineers today.
Yes, thank you, Ed. Indeed, I think we have a lot of experience in our panel today. I don't see myself as so experienced in this specific matter, but I still think there are a few interesting experiences really from our company that are interesting in this context to share. So it's maybe a little bit more specific than a broader overview of the job of engineering. So our company currently, we have 25 employees. About 20 of those are engineers, and almost all of them are involved in software development for our network planning tool. We have chosen, or we saw that we really needed engineers to do the job that we are doing, because we are not a software company that is just about programming. We don't need the best programmers. We need problem solvers. And so we are facing complex problems, and we're trying to invent new algorithms and new ways of solving those problems. And that's really where engineers for us bring in the value for which we need engineers, is really to start from this high-level problem and come up with solutions. And of course, for us, the way to build the solution is to translate an algorithm into source code and produce a software tool from that. But that's just one example of how you can create a solution. And it's much more about this creative thinking for complex problems, what we are interested in, and where we see really engineers standing out through with their knowledge that they gain. Well, maybe not even the knowledge they gain from studying, but at least proving that they can capture a complex domain, and in that domain find new solutions. And now, if I look back, I started in the company 18 years ago after graduating as an engineer. Actually, it seems to be, I didn't remember, but it seems to be today, because I'm getting all kinds of congratulations on LinkedIn for my 18th work anniversary. I totally forgot. Thanks for LinkedIn for reminding me. But so 18 years ago, I started as a software engineer in the company. At that time, there were already 5 people working there, and I joined the team to also take part of the development of a software for network planning. Now, if I compare the way we work together and the way we developed this software 18 years ago and how we do it today in the team, this is a huge difference. First of all, let's say when I came in the office 18 years ago, there was an office with like 5 different rooms, and we were with 2 or 3 people in one room, and we all had our own part of the problem, and we were working on that. And after a month, or for most complex problems, maybe even after 3 months, we would come up with a solution, and we would see how we could integrate that solution into the rest of the software. So it was much more about sitting on your own desk, at your own desk, and solving that problem. Now we are working in an open office space with flex desk, so people sit together as they work together. Every day could be with somebody else, and they work really together in in a much different way. And I don't know if a lot of people are aware of these terms like agile programming. So we are using a lot of principles from that, Scrum things, etc. So for example, now we are working with sprints. Every 2 weeks, we want to have like a next version of the software, and we try to put in as much as possible in those 2 weeks, which means the team is always working together on the same things and working towards a real end, intermediate steps always, but still always something where you can take to the next level, you can test, you can release a beta on. So that's a completely different way of working. It is a way of working which increases a lot the, let's say, time pressure. So for sure there is also this this increased working towards deadlines, and that's less relaxed, I would say. There's always more to be done. It needs to be better and it needs to be faster. I think that's in a lot of industries just the way things are evolving. And what's also quite interesting to see is in software development is the importance of community. So again, 20 years ago, you would develop your own code. Now, today, and that is a bit like what Andy was saying on architect, an engineer as an architect. I would say in our software development, it's also like if you have a problem, first thing is to also look a little bit if for some core components, whether there's not, for example, already somebody who wrote an open source library with a core component that you can just reuse and rather combine pieces of a puzzle into a solution than to start from an empty paper and start from scratch. So there's also a lot more, even outside of the company, that different inputs are given. Another aspect of the job and the engineering for me is on the recruitment. So we are continuously looking for new people, and with this background, an engineering background, with the capabilities that we are looking for. So we are looking even within the engineering, I would say, for the top of class. And that's really a fight for talent. There's a heavy battle for this kind of profiles. So we are recruiting really in the young people, just graduating or a couple of years. And the main reason is actually what Andrzej was saying, is exactly that. People who have experience of 15 or 20 years in some domain, for us, it changes so quickly that it's very hard for us to value those 15 or 20 years in a technology. Actually, the difference in knowledge with somebody who graduates is not that big, while of course, somebody with a lot of experience in general is more costly. So actually there was an interesting article yesterday in the Flemish newspapers, which said, there's 5,000 job openings for engineers. And so there's a lot of job opportunities. But the contradiction is that there's also 2,300 engineers looking for a job and not able to fill it in. And it's especially people who are more familiar with old technologies, and they need to change to a rapidly changing environment. And that's just that's a big challenge. So that's I think very relevant in this topic. And then the last point that I want to make is that the job of an engineer, what we are actually doing from a programming perspective, the software that we are making, is about also partly automating the engineer's job from 10 years ago. 10 years ago, an engineer would also be somebody who could be designing a telecom network and deciding how the network would be built, where to put cabinets, where to put cables. That would be the engineer who would be behind the paper and deciding about those choices. Today, our software is developed to put in a lot of intelligence inside the software so that the tool will take a lot of decisions on its own, will do it even better than a human mind can do, because it can capture much more scenarios and can evaluate much more options. So we actually see that to some extent this evolution of the intelligence and the augmented intelligence is to some extent also changing the role or how to say that, replacing some of the work of engineers. I think it used to be that automation is about replacing simple jobs, repetitive work, but more and more you see the intelligence reaching of computers and softwares reaching levels of what engineers used to do as well. So I'm absolutely sure it won't replace engineers, but it means engineers need to shift more to the architect role and that development role, I think, than the execution role. And I think that's much in line with the rest of the people, but then more from my own experience. Thank you.
Thank you very much, Raf. Some very thought-provoking ideas there. Do we have any questions from the audience? Yeah, please, Peter.
Sorry, the microphone is coming. Could you please tell us your name and where are you from?
Yes, my name is Peter Leonhardt. I'm from British Telecom from England. It's a question regarding the institutions, actually, that you described in Spain, which support your profession. What formal qualifications or certifications can they offer? And which one would you suggest is a good one to do?
Thank you, Peter, from London. Well, our institutions offer two kinds of different certifications. So on one hand, you can get someone related with Scrum methodologies, ITIL methodologies, PMP methodologies, Prince2 methodologies, and personally, I got all of these exams in, I think, 4 months, thanks to the amazing training of our institutions. So I highly recommend you to study these certifications. And on the other hand, we have unofficial certifications which allows you to verify projects for the public administrations. For instance, for building ICTs, structures, also for manage some civil projects, and also for working to the public administration. So if you are interested in these topics, I can share with you the link after the conference.
Thanks both for the question and the answer. One more?
Yeah. So I'd like to ask you all a question regarding researchers, not just engineers, right? Because there is this research part of the training. Those of us who are in academia, we train researchers, we give them PhDs. This means they take longer time to get out in the market. You mentioned, Raf, that you'd rather get young people which are agile and low cost. The question is, do you see a role for researchers in your companies? And second, are you willing to pay for it?
Maybe I can start, because indeed, in our situation, we do have some PhD, so people who graduated as a PhD at the university, we also have some of those with us. But most of the time, those are people who are then into a domain where it's really relevant that they did the research for us. The thing is, we are in quite a niche market, in a niche domain of network planning and algorithms for optimizing those network designs. So a lot of the research that people would do would be a little bit similar to what I said before, that that build-up knowledge is often not interesting for us. And then indeed, it's always more difficult for us to talk about the financial rewards, the wages, if their research was not relevant. So that's But we do have 2-3 PhD students who really focused on a domain very close to our domain, and then it's very valuable for us. So then it's an added value.
If I may step to that question, well, you know, there are actually for me 2 questions. One is research, the second is development. Yeah, Bell Labs is well known for quite basic research and space and transistor and you name it. But I can't imagine our company without still research and development. And development, for me, future will be in the creative people, in the development people, because truth is, well, truth. My opinion is that augmented intelligence will replace us in simple intellectual tasks like economical analysis. Unfortunately, for legal guys, the simple legal analysis will be done by software in the future, but complex things where you really have to put brain, that is human domain. And today everyone knows that the computer have won with Kasparov because computers are good in chess, but they are bad in bridge. Why? Because chess is an algorithmical, easy exercise. Bridge, where you have to take decision in uncertain situation, in not full information, where not full information is available, that's still human domain. It will be replicated, will be copied by augmented intelligence, but the real creative part will be in development and research. And my advice is for the young people, if you put your career and if you want to make bet, you put yourself more in that creative part of the business, because the replication, the easy writing software, C++ or whatever, that will be done in the future by machines. But the interesting development of algorithms and solution close to business, close to things that are complementary to real problems, life, not only the mathematical algorithms, that for human for sure, go that direction, because that would be future and that would be those jobs that are not created yet or found yet.
Thank you, Andrzej. I believe we have another question. Please go ahead.
I'm Julio Navio, I'm the Vice President of the Spanish Telecom Association. Thank you very much for the relevant and interesting discussion in the table. I have an open question, is regarding the high space of education in Europe. I mean, the Bologna reform has provoked different tension between bachelors and Master of Science in Telecommunication and ICT engineers. And in fact, tomorrow in this Congress, we will have a specific roundtable about these results of Bologna and the impact in our studies, in bachelor studies and Master of Science studies in telecommunication. Which is your view from European perspective of the impact in this change in the higher education space and the implication of this reform?
Thank you, Julio. So, from my point of view, the most important thing is that we have to honestly recognize that we have different skills. It's not the same have a bachelor than a Master of Science. So then we should clarify which are our objectives. That means that if we just want to get a job, depending on our skills, we will have different kind of positions. But instead of starting some fights and institutional fights, we should create some common spaces because we are all part of this digital transition. So FEANI, which is the European Association for all kinds of engineers, is the common space for bachelor engineers and also Master of Science engineers. And the European Commission is supporting us, and we are working together. Everybody is feeling comfortable with this situation, and instead of start fighting in this legal process, I think we should admit that we have different skills. They are skills for everybody, and just to create common spaces by supporting with the public administration, with the strongest public administration.
Thank you. Hello, Antonio Moreno, a retired engineer in Madrid. This morning we were told about gravitational waves. And now you, the one on my right, spoke about qubit. So from the universe to the quantum world. Yes. And we were also told that, I think it was today, 2 years ago, when the first LIGO detection of gravitational wave took place. Good, very good day for this. Now, I would like to know about qubit and the computer, quantum computer. Do you think it would be a thing of the near future, or it can be the same that happened to fusion nuclear energy, that it took 50 years from now, but tomorrow it could be another 50 years from now, and it is translating into time from time. How much time do you think it would take for the quantum computer to be a reality?
Oh, I didn't expect that I will earn you such trust that you embark me with such question about the future. And you know, I'm very good at predicting future when it's related to the past, yeah? Somewhere in the future time, I have problems, yeah? But okay. But I will share with you my thinking. This quantum computing, how I see that in the network. Let's go to the perspective of the network and your layers, because engineers like layers. I like 3 layers. So you know, we will be using very powerful devices that will have augmented intelligence in our cars, in our smartphones, yeah? And certain problems will be solved by that software who will be here. For certain problems, that the calculation power of those devices and the edge devices will be not sufficient, they will go to the second layer. There will be this original layer, yeah? And somewhere on the third layer, where the very highly developed augmented intelligence will be needed to be engaged in solving all those problems, there I see the place for the quantum computing, because quantum computing will, any computer can solve the problem of the quantum computing. It's only a question of time, because that's a question of time. If we, and creating algorithms, moduling our life in those quantum computing computers will give us this artificial intelligence insight. Well, they will not give us insight, but modeling that will give us with the answers. There I see the place for this quantum computing computers. And look how what you said exactly. Everything will be connected from quantum life to gravitational, from personal devices to artificial intelligence based in quantum computing. It will be one network. It will be telecommunication, IT, with newest physics and connected together. And it is not a science fiction. It's labs today, and in a couple, 5, 6 years, it will be in deployment. So really, those interesting times come. I don't know if I answered your question, but at least it was close to the subject.
Thanks very much. I'm afraid we're now out of time, but I'd like to thank the panel for their expert opinions and guidance. I'm sure they've raised a lot of interesting points that hopefully some of you would want to take up with them afterwards, and I'd encourage you to do that. It'll enrich tomorrow's debate. And thank you all for participating, and thanks to the panel. Thank you.